Given the production function as Q is equal to A times K to the power A times L to the power B, where Q is the output, A is the total factor productivity, K is the units of capital employed, L is the units of labor employed. A denotes the output elasticity of capital, B denotes the output elasticity of labor. We need to find out the marginal product of labor, marginal product of capital, and marginal rate of technical substitution between labor and capital. Okay, so first thing is first, given this production function, what will be the marginal product of labor? That will be equal to the change in the output due to the change in the units of labor employed. That is the derivative of this function partially with respect to L. And let me use the partial derivative sign here. So we have del Q upon del L. So now, since we need to partially differentiate with respect to L, the exponent of L will become coefficient, so B becomes first coefficient, so we have B, then we have A, K to the power A remains same, and exponent of L will be subtracted by 1, it becomes B minus 1. If I rewrite it, I can write it like this: B, A, K to the power A, L to the power B times L to the power minus 1. Which will become, so we have B, A, K to the power A, L to the power B. Transpose this, rather this can be written as 1 upon L, because if I transpose numerator to denominator, exponent sign changes. It is negative 1 here, it becomes positive 1. So we know this thing is our output, the given production function. So we will get B times Q upon L. This will be the marginal product of labor. So this is our marginal product of labor. Likewise, marginal product of capital will be the derivative of the production function with respect to capital. That is the change in the output due to the change in the units of capital employed. Okay, so this time we take derivative with respect to K. The exponent of K becomes coefficient, so we have A times A, K to the power exponent will subtracted by 1, get subtracted by 1, and L to the power B will remain same because we are taking derivative with respect to what we call K. Okay, so solving further, so marginal product of capital will be equal to, so we have A times capital A, K to the power alpha, A times K to the power minus 1, L to the power B. So we can rewrite it like this. So we have A capital A, K to the power A, and transpose it to denominator. So exponent sign will change, L to the power B will remain same. So we will get here A capital A, K to the power A, L to the power B divided by K. This thing is our ordinal production function, so we will get A times Q divided by K. This is our marginal product of capital. Now we need to find out marginal rate of technical substitution between labor and capital. It is simply the ratio of marginal product of labor and marginal product of capital. Okay, so if we have labor on the horizontal axis, capital on the vertical axis, if this is our isocont, okay, so MRTS shows us the slope of the what we call the isocont here, and it is the ratio of marginal product of labor and capital. So marginal product of labor is this BQ upon L, and marginal product of capital is AQ upon K. Solving further, we will get BQ upon L. So transpose this term, it will get multiplied but reciprocated. It becomes K upon AQ. Q and Q gets cancelled rather. So we will get B upon A times K upon L. This will be the marginal rate of technical substitution.